Okay, we're in section 2.4, and this is number 84 from page 213. The very last problem of the homework. It looks like a huge paragraph. It looks long and complicated like most story problems, so we think, and we might be tired at the end of the assignment, and so that could be why we look at this and go, I don't know, this is probably hard. I don't have the energy to do it. But if you just read the problem, you realize that they're not asking you to do very much here. You're just reading numbers off the graph. And I'm sorry that my image turned out to be so blurry, but I think we can make do and still figure things out. So here we have the graph that represents the height of a ball. Along the y-axis we have its height in feet, and then along the x-axis we have time in seconds. A ball is thrown straight up into the air. The function defined by y equals h of t is the graph gives the height of the ball in feet at t seconds. Note, the graph does not show the path of the ball. The ball is rising straight up and then falling straight down. So what that's telling us is the ball is doing something like this. Starting right about at this height, being thrown straight up. Imagine that was straight. And then going straight down. But the reason the graph looks like a parabola and not just a line segment is because we are looking at what's happening over the course of time. Don't let that statement throw you. It's not going to change what you do in this problem. So let's just go through the parts one by one. Part A, what is the height of the ball at 2 seconds? Okay, all we need to do is locate 2 seconds, find where that falls on the graph, over to here. Okay, what is that height? Let's see. If this is 64 and this is 128 and there are 4 sections in between, each one is 16. So this was 192 plus 16 plus 16 plus 16. And I sure wish I could read my numbers a little bit better. Let's see, what's 192 plus 48? Is that 240? So for part A, we have 240 feet. Okay, now I think I'll erase the markings that I made on the graph so that I can mark anew for the next part. Part B, when will the height be 192? All right, let's find the height of 192 and go over to the graph and then find its time. So if we go down, that looks like at 1 second, and there's another one. Go across and down, and that is 5 seconds. So we'll be at a height of 192 feet at 1 second and at 5 seconds. All right, part C. We'll erase those markings. During what time intervals is the ball going up? So this is a bit like the previous problems we had where we had to talk about increasing, decreasing, and constant. And we can see the ball is going up in this section here, and then it's going down in this section there. So we need to find the time intervals. So it's going up between time 0 and what would this be, about 3? Up 0 seconds to 3 seconds. And then for down, 3 seconds to 7 seconds. Okay, let's see what's next. How high does the ball go? And when does the ball reach its maximum height? So we're looking for that vertex of that parabola right about here. Looks like that maximum height is 256. And when does that occur? At time 3. Okay, and then the last part, after how many seconds does the ball hit the ground? Okay, so here it is hitting the ground. What's the time? 7. So the answer to that would be 7 seconds.